Hello, it's me, Mr. Barbera, over here in the corner. I want to talk to you about probability a little bit, so let's go ahead and get started. We're going to start with the probability scale. Before we can talk about the scale, though, we need to make sure we know what probability is. So probability is the chance of something happening or not happening. It's a way to describe the likelihood that an event will happen. And so the probability scale is a way, so all probabilities can be described with a number from 0 to 1. Where 0 is the least likely to happen, that's something that's impossible, and 1 is something that is certain. So you can see here, so 0, like I said, is impossible. 1 would be certain it's definitely going to happen. If you have a probability of 0.5, or you can see 1/2 down here on our scale, that would mean that something has an even chance of happening or not happening. Sometimes we'll call that equally likely and unlikely. Now, in between 0 and 1/2 and 1/2 and 1, there are two other words that we would use here. So something that has a probability between 0 and 0.5, we'd call that unlikely. So it has less than a 50% or less than a half chance of happening. Anything that has more than a 50% chance of happening, but less than a certain 100% chance, would be considered likely. So that's likely to happen. More than half the time that's going to happen. So let's try these here. What word would you use to describe the following situations? Getting heads when flipping a coin. Let's see what you guys got there. That should be an even chance. So a coin has two sides. You have a 50% chance of getting heads. Here's another one. Pulling a blue marble out of a bag of only red marbles. Let's see how you did. That would be impossible because if there's only red marbles in there, you cannot get a red, blue marble. You can only get red. Another here. Tomorrow being Saturday if today is Friday. Let's see. That would be certain or one. That's definitely going to happen. If today's Saturday, or sorry, if today is Friday, tomorrow is definitely going to be Saturday. We have one more here, maybe two more. Rolling a 2 on a 6-sided die. Let's see. That would be unlikely. So only one side there out of the 6 sides is a 2, and there are 6 sides total. So that's less than 50% chance. Spinning yellow on a spinner that is mostly yellow, so not all yellow. See what you guys said? The answer should be likely. So if it's mostly yellow, that means more than half of it is yellow. So it would be more than 50% chance. All right. So since probabilities can be described with values between 0 and 1, they can be written as decimals, fractions, or really any ratio, and percents. How do we convert from a fraction to a decimal? See if you remember how we do that. All right, so you got a chance to reflect there for a moment. We divide the numerator by the denominator if we want to change a fraction into a decimal. So I gave you an example here, 1/4. The numerator is the 1. The denominator is the 4. So you can divide 1 divided by 4 and get 0.25. All right, here's some practice. Go ahead and convert 3/5 to a decimal for me. All right, and let's see if you got it. 3/5, 3 divided by 5 should have been 0.6. All right, now calculating probability. There are two types of probability that we're going to deal with. We're going to deal with experimental probability and theoretical probability. Now, experimental probability, this is probability that is the ratio of the amount of times an event occurs to the number of times the activity is performed. So we're comparing, let's say I roll a dice, we're comparing how many times I get the number I'm looking for compared to how many times I rolled the dice. I think I have another example here. So if you flip a coin 40 times, in those 40 flips, you get heads 27 times. So if I wanted the experimental probability of getting heads here, I'm going to look at what I actually did. I got 27 out of 40. So that would be 27 divided by 40, or 0.675 would be the probability there. 27 over 40 is okay too. Now, theoretical probability, we don't actually do an experiment. Theoretical probability is the ratio of favorable outcomes to the total number of outcomes. Sorry, I should put an S there. So this is when we're looking at the situation before we actually do an experiment, or after, but we're not doing the experiment. We're just looking at how things are set up. So a coin has two sides. They're each equally likely. This is just the normal coin rules. So we would have, if we wanted to know the probability, the theoretical probability of getting heads, it would be 1 to 2, or 1/2. 1 divided by 2 is 0.5. So here we're comparing how the coin is set up. We have 1 heads and we have 2 total sides, and that's where our theoretical probability comes from. All right, so you're going to tell me here, is this experimental or theoretical? The probability of rolling a 4 on a 6-sided die is 1/6 because there is 1 side with a 4 and 6 total sides. Do you think that is experimental or theoretical? All right, let's see how you did. That is theoretical because we haven't actually rolled the die. We're just looking at how the die is set up and comparing the number of sides that have a 4 compared to the total number of sides. We'll try another one here. Is this experimental or theoretical? You roll a die 30 times and roll a 5 7 times. That's a little funky there. The probability of getting a 5 is 7 out of 10. So is this experimental or theoretical? Let's see. This would be experimental because we actually rolled the die. We didn't just look at how the die was set up. We looked at the results that we got from an experiment. All right, so that is a little bit about scale, theoretical and experimental probability, and how to find them.